Of the four Maxwell equations, the first belongs to Carl Friedrich Gauss, one of the greatest mathematicians who ever lived. Gauss's law for electricity is simple to write, but profound to understand. It tells us that electric charges are the sources of electric fields. Positive charges create fields that point outward, negative charges create fields that point inward. But let me show you, not with equations, but with something you can see. In the lab, I charge this sphere positively. The field detector shows the same pattern, radial lines shooting outward. The positive charge manufactures electric field lines. It is a source. Look at this fountain. Water sprays out from the center, outward in all directions. A positive electric charge does the same thing. It is a source of electric field lines. The field lines radiate outward just like the water. In the lab, I charge this sphere negatively. The field detector shows field lines pointing inward, the opposite of the positive charge. Negative charges eat field lines. They are sinks. Now look at this drain. Water flows inward, disappearing into the hole. A negative electric charge does the same thing. It is a sink. It eats electric field lines. The field lines point inward toward the negative charge. Look at this net, a closed surface around the fountain. Water sprays out from the center. It passes through the net and leaves. That outward flow is what Gauss called flux. Now I place the same closed surface around the drain. Water flows inward through the net and into the hole. That is negative flux. The net catches the inward flow. Negative charge, net flux inward. So here is Gauss's law. Positive charge source, net flux outward. Negative charge sink, net flux inward. Depends only on the charge inside. More charge, more flux. No charge, zero flux. Gauss's law for electricity. Let me show you exactly what each part means without reading symbols like a robot. I will point, you listen. This whole left side, divergence of the electric field, asks one question. At any given point in space, is the electric field spreading outward, coming inward, or neither? This is a mathematical operator invented by William Rowan Hamilton. Del is a vector operator. It knows direction and does calculus. In coordinates, del is the vector of partial derivatives. Partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. It knows how things change in every direction. This dot means dot product, a mathematical way of multiplying vectors that cares about direction. It takes the change measure and the electric field and tells us how much field flows outward. On the right side, charge density divided by a constant. Charge density is how much charge is packed into a volume. The constant converts charge into flux. This epsilon naught is the permittivity of free space, a fixed number. It tells us how much the vacuum resists electric fields. It is the bridge between charge and flux. This is the integral form, often easier to use. The words closed surface integral mean add up over an entire closed surface, a sphere, a cube, any shape that fully encloses a volume. Inside the integral, E.dA. This is the flux through a tiny patch of the surface. The electric field times the area of the patch times the cosine of the angle between them. I place this closed surface, the net, around the fountain. Water sprays outward. The net catches the water flowing out. That outward flow is flux. The closed surface does not have to be a sphere. I can use any shape, lumpy, uneven, any size. The total water flowing out is the same. Only the source inside matters. That is Gauss's law for electricity, the first of Maxwell's four equations. But there is a second Gauss's law for magnetism. It tells a very different story. Join me. That is our next journey. Join me, and I will show you why magnetic fields are different and what that means for the universe. That is Gauss's law for electricity, the first of Maxwell's four equations. But there is a second Gauss's law for magnetism. It tells a very different story. That is our next journey.